Hello dear users of digital photogrammetric workstation PHOTOMOD. We are going on a series of video tutorials how to work in PHOTOMOD 6. Last time we measured ground control points and tie points. Today's video tutorial is devoted to a block adjustment. Let's start PHOTOMOD and open Project Island. An adjustment is a calculation of exterior orientation parameters and defining of the all points coordinates of the block. Minimal requirement for a block adjustment performance is the presence of internal and relative orientation of images. Let's open block adjustment toolbar and clarify its parameters. For adjustment of the central projection block of images, three basic methods are provided: initial approximation, by independent strips or by block scheme, independent stereo pairs method, and bundle adjustment. When it's a question of a big project processing, these methods should be used step by step. Initial approximation is used for identification of rough errors. For example, for identification of non-correspondence of GCP's coordinate system and the project coordinate system. Independent stereo pairs method is used for identification of small errors. Bundle adjustment method provides a final adjustment of a block. Using of independent strips for calculation of initial approximation is based on preliminary building of independent stereo pairs for images of every strip that will be combined in one model afterwards. A principal condition for using of this method is the presence of in-strip tie points enough for stereo pairs building. Basic parameters of this method looks like this. Maximum point distance enables to automatically delete from the adjustment tie points at distance from which two projection centers is more than a value specified in this field. It's recommended to specify a value not more than 100 bases. Recommended range of maximum strip length values is 10-30 images. Strips with greater lengths will be divided into parts of size specified. Given parameters are used for decrease of systematic errors number. Adjustment accuracy and equations weights are recommended to leave as is. In quality speed ratio, value 0.5 is an optimal one. Options of using of GCP and projection centers coordinates are activated here. Okay. If inside strips tie points are not enough, it's possible to use a block adjustment. It's possible to use a block scheme as an initial approximation. A block layout scheme will be used as a basis of the adjustment. In particular, given method is applied for a single image adjustment. As you remember from last video tutorials, in our project we haven't problems with in-strip tie points. Relative orientation have been completed for all stereo pairs of the project successfully. That means we will use independent strips as an initial approximation. As I already told, a block adjustment by initial approximation method is used in big projects for identification of rough errors. For identification of small errors in such big projects, independent stereo pairs method is used, and final adjustment after fixing of all big and small errors is performed by bundle adjustment method. When it's a question of small project adjustment, like for example in our case, it's recommended to use a bundle adjustment method directly. Settings of this method looks like this. Default parameters of measurement precision correspond to half over pixel both for manual and automatic measurements. Actual values of measurement precisions in images can be seen in relative orientation report. These values are located in RMS of vertical parallax column. As we see, their values vary within 0.2, 0.3 pixels. Thus, default measurement precisions in bundle adjustment settings exceed these values significantly. For bundle adjustment, it is recommended to use just data and accuracy of which seems to be satisfactory. Since in our test project angles accuracy is not good, I deactivate an option of using of exterior orientation angles. Change of source data weights to the value more than 1 is equivalent of increase of the initial accuracy. For example, if initially 20 centimeters accuracy was specified for projection centers, double weight for it means automatic increase of the accuracies to 10 centimeter. Adjustment accuracy 0.5 is an optimal speed quality ratio. If necessary to provide an increase of result repeatability, it's available to increase adjustment accuracy to 0.9, for example. But in this way a process speed can be slowed down significantly. Minimal distance between projection centers and objects can be increased when it's a question of processing of terrestrial images. Let's leave it as is. Minimization of residuals on images correspond to classic photogrammetric processing. When it's a question of UAS data processing, it's recommended to activate option of minimization residuals in 3D space. While using this option, an adjustment speed and results convergence will be high. In case of multiple starting of adjustment, common option use current solution enables to diminish processing time due to automatic using of iterations calculated on the previous steps of the adjustment. Free model adjustment is recommended to perform in two cases. The first one when GCPs and projection centers are not in the project, and the second one when these data take place in the project, but it's necessary to estimate just adjustment accuracy by type points. Depending on a reference model, a rotation and a shift of projection centers coordinates is performed either by block scheme or relatively a nominal coordinate origin in the center of the first image. Here it's also necessary to specify a value of survey basis. The more realistic it will be specified, the more true residuals in type points will be. Conditionally speaking, if value specified will differ from actual value in 2 times, adjustment residuals by type points will be bigger in 2 times as well. If projection centers are loaded into the project, a basis value will be calculated as a difference between x coordinates of 2 neighboring images. In our case, about 220 meters. If in the project there is not exterior orientation data in general, it's necessary to calculate a basis value manually. Let's open images containing marker. Let's select identical point in 2 neighboring images. x-coordinate of the second image minus x-coordinate of the first image in millimeters will be a basis that we should to identify. The result is about 38 millimeters. Remembering that camera pixel size in x-axis is 12 microns, calculate that a survey basis equals 38 divided by 0.012 is 3166 pixels. Taking into account that GSD is about 7 centimeters, we get a value of survey basis 3166 multiplied by 7 is 22,166 centimeters. That is approximately 221 meters. Before, in block scheme window, we will see points with non-correct measurements. The worst ones can be filtered automatically. Systematic error compensation. If in advance it's known that projection center's coordinates are obtained from GPS IMU system with some constant inaccuracy, a compensation of them, common for a block or common for a strip, will be depend on a direction of systematic errors. Conditionally speaking, in case of one strip linear survey, systematic errors most likely will be oriented in one direction, since a plane did not turn round. In this case, a compensation should be one common for a block. If it was a several strip survey, when a plane turned round time to time, systematic errors will be oriented in various opposite directions depending on a strip. In this case, a compensation should be one common for a strip. Pay attention that systematic error compensation without GCPs in the project can be done just by block scheme. Regarding a self-calibration, it should be noted that it will work just together with a bundle adjustment method. Using a self-calibration, it's possible to restore unknown parameters of camera or make more accurate available parameters of the camera. Necessary condition of starting of self-calibration command is the presence of sufficient number of GCP in the project. I think separate video tutorial will be dedicated to specification of the self-calibration parameters when we will talk about processing of UAS images. If necessary, it's possible to adjust not only a block entirely, but its separate part, sub-block as well. It's useful while controlling separate inaccurate measurements in local place of a strip, and it takes less time in comparison with the whole block adjustment. Option Check Consistency is activated default. It enables to check a sufficiency of source data for the adjustment, a presence of projection centers, type points and ground control points. If there is not a sufficient number of source data and the option is activated, corresponding error message will appear. If there is not a sufficient number of source data but the option is deactivated, the adjustment, even if with some inaccuracies, will be done. On the bookmark coordinate system, the coordinate system of the project is kept in default. If necessary, it can be changed. On the bookmark report, it's possible to specify parameters that will be shown in the adjustment report. It's possible to specify a model, units of angles measurement, and residual print format here. In addition, acceptable residuals as specified in this window. Following Russian instruction on photogrammetric works, photopographic mapping in 1000 scale, acceptable residuals of GCP in XY plane are 20 centimeters and in Z height 1/3 of contour interval, that is about 30 centimeters. If a task is to create an orthophoto, acceptable residuals of GCPs will be not so strong. To define an expected adjustment accuracy, which should correspond to acceptable residuals, a ratio of camera focal lengths to survey basis should be taken into account. If to consider that XY plane accuracy of the adjustment is about 1 pixel, that accuracy of the adjustment will be equal 1 pixel multiplied by a ratio of camera focal lengths 120 mm in our case, and the survey basis in image scale 38 mm. That is, that accuracy of the adjustment equals about 3.5 pixels. Firstly, let's adjust a block in a free model in order to control residuals by ties. Compute. In the window of the brief residuals report, it's possible to see average for a block, values of residuals, and measurements for tie points. Numbers with the star symbols on the top of numbers show exceeding of acceptable residuals for corresponding parameters, but we have not such numbers with a star in the bottom. Value of sigma shows how much adjustment errors correspond to a priori accuracy of points coordinate measurements. If a priori values of accuracy are specified right, sigma values will be close to 1, between 0.7 and 1.4. If sigma exceeds value 1 significantly, it indicates the errors in points coordinate measurements and shows that a priori accuracies of GCPs and projection centers are overestimated. If sigma is significantly less than 1, it demonstrates that a priori accuracies of GCPs and projection centers are underestimated. If to increase values of accuracy for exterior orientation data, it's possible to achieve better values of adjustment accuracy. In block layout window, make sure that option adjustment results is activated. It enables to see adjustment errors for each measured point visually. In Layers Manager, make invisible a block scheme layer and raster layer if necessary. Displaying of residuals in a block scheme window is specified in Display Options bar. XY errors of type points are represented by cross-like symbols. Z errors are shown by vertical lines. Scale of errors view, real one or in the screen are specified here. Green lines indicate errors inside acceptable residuals, red lines indicate errors exceeding acceptable residuals. Apart from errors by ties between stereo pairs, which are measured in meters, there is also mode of viewing of errors by ties on images. In later case, errors are calculated in millimeters in image coordinate system. In order to show in the block scheme window just points our acceptable residuals, you should specify corresponding parameters of the filter and then activate the filter itself. Parameters of filtration are specified here. Point filtration is based on such points properties as the presence or an absence of measured coordinates, I mean x, y and z coordinates, number of images on which point is measured, and many others parameters. Type points constitute points without coordinates. Let's leave visible just points, errors of which exceed acceptable residuals. Activate by residual value option and select our acceptable residuals option. Press OK. In our project we have not points exceeding acceptable residuals. Now let's deactivate a free model and adjust the block taking into account GCP's compute. I show errors by ground in X, Y and Z. XY errors of GCPs are shown by lines with the circles on the top. Their direction corresponds to a direction of points shift in theoretically right position. The bigger an error, the bigger line size. Z height errors are lines with a crossbar on the top. While analyzing a graphic representation of the errors, it can be noticed that a maximum error in XY plane is specified for GCP with a number that looks like this. If to select it and press button measure, it would be possible to check its position in the point measurement window. And really, this point is measured not right. GCP error vector shows a direction of point right position. Let's correct the position of this point. It should be measured here. Apply. OK. Readjust the block. And now number of errors is decreased, including mean absolute value in residuals report window. From the residuals visualization, it follows that projection centers errors are over acceptable residuals. And as you see, these errors have the same direction. It helps us to consider that there is a systematic inaccuracy in measurements of projection centers. We can compensate it with using corresponding settings of the adjustment. Parameters of the adjustment, systematic error compensation, common for block. OK, compute. To supervise an adjustment, a state of some points can be changed from control to check. Checkpoints should be selected in a such way they will be surrounded by GCPs from different directions. For example, I want to change the state of these control points to check, readjust block, and corresponding information about the accuracy of control projection centers will simultaneously appear in the residuals report window. If necessary, it's possible to shape a full adjustment report for each stereo pair and for every point of the project. You can save it in separate file or print at once. A full table with source and with adjusted coordinates of the points is available with the button Triangulation Points List. If necessary, it's also possible to export results of PHOTOMOD adjustment to another photogrammetric workstations or vice versa, to import adjustment results from the third-party DPW to PHOTOMOD. A list of available formats for export import looks like this. After completing of adjustment, I press button Save Adjustment Results and rebuild the block layout, taking into account adjustment results. Well, today I have finished a procedure of a block adjustment